For more problems and videos like this for linear algebra, you can take a look at Sarai Studies, link is in the description box below.
Today we're going to talk about subspaces associated with the matrix. So for any matrix that you have with m rows and n columns, there are 3 subspaces associated with it. Now what do I mean by subspace? Well, in this case, instead of visualizing with a graph, let's look at subspaces from the perspective of what they really are. They're just sets. They're a collection of things. In this case, they're a collection of vectors. So the first one is the column space, which we just denote as col of A. Then the second one is the row space, which we denote as row of A. And the final one is null space, which we just denote as null of A. The column space is simply just the span of the columns of your matrix. The row space is simply just the span of the rows of your matrix. And your null space is simply just all of your vectors in your vector space, who when multiplied by your matrix are killed and they just go to 0. So in other words, you're just solving for AX is equal to 0, and you're just trying to find all your vectors that your matrix kills to 0. Now let's do an example. Let's say that I want you to find the generating set for the column space of A and the row space of A, where A is this matrix. So if you go back to your definition, the column space of A is literally the span of the columns of A. You're going to write span, and you're going to highlight your columns, and then you're just going to put them right here. And these are vectors. So add your little brackets, and that's it. And that's it. That is literally the column space of A. Just take your columns, put them in vectors inside the span. That's it. Now what about the row space of A? Well, the row space of A is the span of the rows of A. You're going to write span, and you're going to take each row. So we have 3 rows. They are vectors, and then just plop the numbers in there. So we have 1, 2, 0, 3. The second row is 0, 0, 1, 2. And the third row is 0, 0, 0, 0. And that's it. That is the row space of this matrix A. Now what about the null space? So if they want you to find a generating set for the null space of A, you just have to do AX is equal to 0, then you're really just trying to find the vectors that A sends to 0, meaning your B values, your equal to values are 0. So you just want to find your X variables that this matrix A multiplies to get 0. And to solve a system, we just want it to be in reduced row echelon form. So we can check the conditions. That's ZO plus 1C. Remember that when we're checking the conditions, we're only checking of the coefficient matrix A. So are all 0 rows at the bottom of the matrix, of the coefficient matrix? Yes. Does it pass a staircase hack? We'll identify your leading entries. This is a leading entry. This is a leading entry. This has no leading entries. So you start with the leading entry, keep going until you see another leading entry, then you can go down and then keep going. The height of each step is 1, so we're good there. Are all entries below the leading entry 0? Well, this is leading entry, this leading entry. Are the entries below 0? Yes. Entry below 0? Yes. So we know it's in row echelon form, but is it in reduced row echelon form? Well, all the leading entries have to be 1. Are they 1? Yes. And they should be the only one in the column. That's what C stands for. In other words, this should be the only number that's not 0 in that column. This is the only one there. This is the only one there. We're good. So this is already in reduced row echelon form. So let's actually write them out. So we have 1x plus 2x2, because remember, every column is associated with a variable. 0x3 plus 3x4 is equal to 0. That's my first row. So we went from a matrix to a system. And then this just says 0 is equal to 0. This tells me that there's going to be many solutions. So I can get rid of that. I can also get rid of these zeros. And I can move everything over. I can get rid of the 1s because that's insignificant. And these are the solutions to my system, but they're not very clear, which is why we have parametric form, where we describe our solutions in a better, more clear way, and that depends on your free variable. So which are your free variables? Well, they are the variables associated with the columns that did not have pivots. So remember that your pivot positions are your leading entries in reduced row echelon form. So that's this one, and then over here that's this one. And over here there weren't any leading entries because everything is 0. Remember that the leading entry is the first number that you see in each row that's not 0. Then those columns that don't have pivot positions, their associated variables are what we call free variables. So that's x2 and x4. So we can say x2 is equal to x2 and x4 is equal to x4. Meaning they can just be anything that we want them to be. And so the strategy of parametric form is to write everything else in terms of these two variables, x2 and x4. So that just means move anytime you see x4 and x2 to the other side. So there we have that. And then over here I would move this to this side, and then we have that. And now we have our solutions. We have very specific, detailed solutions. Then we want it in vector form. There's parametric form, which is just the normal, leave your answer like this, but then there's parametric vector form, which is basically taking your free variables, which were x2 and x4, putting them like so, and then you're just going to go through every single row. Then in order, you're just going to ask yourself, okay, how many x2s do I see? I see -2. Then for the next one, how many x2s do I see? Just one of them. How many x2s do I see? 0. How many x2s do I see? 0. Then you do the same thing for x4. For the first row, how many x4s do I see? -3. How many x4s do I see? 0. How many x4s do I see? -2. How many x4s do I see? 1. And then you say that your null space is equal to the combination of these two vectors and the x2 and x4 variables, which are free to be anything, which is why they're called free variables. And whatever combination of these variables that we have with these vectors is going to send us to 0, then I can say that all of the combinations, so span of these two vectors, -2, 1, 0, 0, and -3, 0, -2, 1, be called my subspace, because remember the theorem that we use that a span is a subspace? So this translates to this, and so then we can say that null of A is equal to the span, all of the linear combinations of these vectors. And we say that null of A is a subspace, span is a subspace. And so this here is a generating set for null of A. It's going to literally generate the null space of A. And that's it for this video. I'll see you in the next.